today we want to talk about one last step in using those congruent triangles. So we've been talking about how to get triangles congruent using hypotenuse, leg, side, 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 angle, side, angle, angle, side, or angle, side, angle, right? Those 5 options. And now we want to take it one last step. And that one last step is to get the individual parts congruent. Okay? Back when we were talking about proving polygons or figures congruent, we had to get all the parts and all the sides, all the angles congruent, and that was a lot of work. So we simplified it down to those 5 theorems that let us get triangles congruent. And from there, we can try to get the individual parts, the corresponding parts, congruent. So for example, are triangles ABC and DEF congruent? Yes, why? Because they have 2 angles congruent and 1 pair of sides congruent, right? Which theorem can we use? Angle, side, angle, okay? So these triangles are congruent by angle, side, angle. The side is between the 2 angles, right? And the nice thing is then, if I asked you to prove that EF was congruent to BC, you could do that. Because once the triangles are congruent, then all the other parts get to be congruent as well. Does that make sense? So then AC will be congruent to DF, and angle F will be congruent to angle C. All the 6 parts fall into place because we managed to find the right 3 parts congruent. Does that make sense? And we're going to have an abbreviation for that, and we don't want to have to write it down the whole long thing every time. So I'd like you to write down somewhere at the top of your paper CPCTC. CPTCT. Did it wrong. I said it wrong. CPCTC. Lots of C's. CPCTC. Okay? So we're writing CPCTC. That's our abbreviation for corresponding parts of congruent triangles are congruent. Okay? So I'd like you to write down also by that CPCTC that corresponding parts of congruent triangles are congruent. That way you only have to write it one time. Corresponding parts of congruent triangles are congruent. That way nobody asks me later, Mrs. Bender, what does CPCTC stand for? It stands for corresponding parts of congruent triangles are congruent. Write it down once, somewhere where you can refer back to it. Corresponding parts of congruent triangles are congruent. We're just going to abbreviate it. CPCTC is how we make it short. It stands for corresponding parts of congruent triangles are congruent. In other words, once the triangles are congruent, all the parts are congruent. If they're in the same location, right? It should be, right? Okay? Should be common sense. Once you get the triangles congruent, then we've defined all the parts to be congruent as well. Make sense? Okay. All right, so here we go. Can we say that segment AD, I'm going to put an pointer to it so I know that that's what we're talking about. Segment AD is congruent to segment BC. If so, how? So we are given this angle at D is congruent to angle B, And this angle at A is congruent to this angle at C. So we've got two parts congruent to two parts of a triangle. The only way we can use two parts is if it's a hypotenuse and a leg. Do we have a hypotenuse and a leg? No, no right triangles. So we've got to find a third part. Is angle, angle, angle ever going to work, Zach? No, it will not. So we've got to find a side, right? Since we have to find a side, we're going to look for a side that both triangles share. Do both triangles share a side? Which one? I trace over this triangle. Am I going to trace twice when I trace over the two triangles? Does everyone see that I'll trace one line twice? Yep, AC. AC is congruent to itself, isn't it? So yes, AC congruent to itself. It's in both triangles, right? So we could use reflexive, right? And now that that's happened, how are the two triangles congruent? How are the two triangles congruent? Angle, angle, side. A's. Everybody wants A's, right? So triangles congruent by A's. Angle, angle, side. Because the side's not between these two angles. It's non-included. It's excluded. It's outside of them, right? And once we get the triangles congruent, then these two are congruent by, what's that thing I told you to write down so we wouldn't have to write it again? Good, by CPCTC, okay? So then the AD congruent to BC by CPCTC, okay? Okay. Does that make sense? Everybody good with this? Okay. Jaden, can you please take notes on what we're doing? No, come on. Okay, everybody good? Question on this one. Okay, let's look at another example. Okay. So you have a choice here today on your assignment. Okay, I don't care which one you do. If you don't like formal proofs, you don't have to do a formal proof. If you do, you can write a 2-column proof, and that's perfect. Okay, but your book is going to ask you to plan a proof to show that two parts are congruent. Okay, so it doesn't have to be a formal one. But you don't want to miss any parts. Okay, so if we want to prove that GK and NK are congruent, GK and NK, then we've got to get those two triangles congruent to each other first. Okay? So what I want to see on your assignment today is I've given you a printout of all of the problems, right? So that you don't have to redraw the figures. But what I need to see on your assignment today is that you're making the marks on your picture, right? The reason I did this was so we wouldn't write in our books. You're making the marks on the pictures and you're telling me what you would do to prove these guys congruent. Okay? All right, so when it says HK bisects angle GKN, HK bisects angle GKN, it bisects this big angle. What does that mean? Okay, guys, please. Let's focus, please. Jaden, please. Okay. HK is bisecting an angle. What does it mean if you bisect an angle? You split it in half, exactly half, 2 equal parts, right? So we need to show that this broke it into 2 equal parts, show those arcs. Okay? So angle GKH is congruent to what? NKH. Good. Bisector. All right, we've got an angle congruent to an angle. What else do they tell us? G is congruent to N, so I want to see a double arc at G and a double arc at N. So make your arcs. That's looking promising. I see an angle congruent to an two angles congruent to two angles, right? What are we missing? A side, because angle, angle, angle will never work. Okay, so we're looking for a side. So can we get a side congruent to a side? Which one? HK, it's in both. Okay, HK congruent to itself. It's in both triangles, or you can say it's in both triangles, right? So the triangles are congruent by so this would have been reflexive, right? By angle, is it angle side angle or angle angle side? Angle angle side, right? The side's not in between the two angles, it's excluded, it's outside, non-included. So by angle angle side, the triangles are congruent. So why is GK congruent to NK? No. We got the triangles congruent, so now why are the individual pieces congruent? CP, CTC. Okay? So not a formal proof, just tell me all the pieces. Does that make sense? Okay? I'll let you try the next one. That would be a 2-column. But here's just to plan the proof. I saw that. Is yours? I don't have another pencil. It didn't come back to me. It's not in the chalkboard tray. Make your marks based on your given. We've got 2 angles congruent and 2 other angles congruent. The first 2 angles get a single set of arcs. The second 2 angles get a double set of arcs. An angle, angle, angle's not going to cut it. So you've got to find a side. So you've got your arcs.
Yeah, I got my arc. No, I got my arc.
Could be like this.
It would be like
Well, it needs to be congruent.
that. But we don't care about those, right? Because those weren't given. A, A to B to D, A to B to D.
Are all equal.
But it doesn't say anything about A or C. Notice how A is not in the middle. When you're naming angles, it has to be the middle angle, the middle letter. So from A to B to D is 1. That's congruent to C to B to D. And then B to D to A is congruent to B to D to C. So these guys are correct. We don't need the A and the C. Okay. So how do we get a side congruent?
She just said it was correct.
How do we get a side congruent? Yeah, mark it. We've got a reflexive, right? BD congruent to itself. So why are the triangles congruent? Angle, side, angle. So why is AB going to be congruent to CB? Why is AB, why are the extra parts congruent then? What's our big long thing that we don't want to have to write? Corresponding parts of congruent triangles are congruent. So we get the triangles congruent, and then the parts have to be congruent. Whenever you're asked to get parts of a triangle congruent to parts, it's always going to be CPCTC. But you've got to get the triangles congruent first. Okay? Make sense? CPCTC. All right, last one. Make your marks. Mark them. We want a single arc at F, a single arc at M, a double arc at angle 1, a double arc at angle 2, okay? Got your arcs there? All right, so now, okay, so we've got an angle, right, with an angle, and then we've got another angle up here at 1 and 2, so double arc with those guys. Okay, so 2 angles is good, but we have to have a side with it. So which side is in both triangles?
This.
Yep. So make that mark and say LP is congruent to itself. And that's just reflexive, right? Now why are the triangles congruent?
Isn't it because of this?
Yep, we have an angle, and a side, right?
Yeah.
Congruent to an angle, and a side. So we can use A's. Everybody wants A's. Okay? All right, so once you recognize that PL is inside both triangles, then we know that the 2 triangles have to be congruent. Triangle FLP congruent to triangle MPL by what? AAS. The side's not in the middle of it, it's outside, so we have to say AAS. And then the parts are congruent by CPCTC. Good. Okay. Make sense? Questions on this? You're going to see a pattern. We're going to have that happen every single time. Okay? All right. Assignment. Page 281, 3 through 12, and 19. Page 381, 3 through 12, and 19.